is Wednesday. If I'm not here, then go downstairs and Phil will have it. But more than likely I'll be here. I just called them this morning. What's that? Wednesday. Yeah. Okay. What we're going to do is going to try to be a little more precise on when we do these proofs. And I'm looking on page 205 and 38. So what we're trying to prove in this, that angle GBH is congruent to angle EHD. So it's this angle congruent to this angle. That's what they're trying to prove, or they want us to prove. And what they have, so if we're doing a proof, they're saying angle EBH is equal to angle GHD, and that's equal to 90 degrees. And this is given. So EDH, so they're saying this one and this one, and they're actually, it's actually 90. I guess you can draw a little box. And then the second thing is that DE is congruent to HG, and that's given. Okay, with that much information, DE, so it's this one and this one are congruent. So what's going to be the strategy to show the two red angles are congruent?
Can you say DE, line DE is equal to the line which is G?
Yeah, it's congruent to HG. So you're, well, what's going to be your strategy?
Okay, you say HE is congruent to DG line.
I'm not sure. That
If you do DH, line DH is equal to line HD.
okay, but what is that going to end up doing? What is what is the ultimate thing that you're gonna show?
That both triangles, EDH and GHD, are congruent.
Okay, so you're gonna show congruence of the DEDH and GHD, right? You can show those two triangles are congruent. Then you can do the two red angles are congruent by corresponding parts of congruent triangles. And so now, what you're going to do is to do that, to show those two triangles are congruent, what is the next thing you have to do? And the designation of the sides, the way you letter them, have got to be correct in direction. So what are you going to do?
What I suggested earlier, the line DH is equal to line HD.
So it's DH is congruent to HD. And that's what?
Reflexive.
Okay, so it's a reflexive property. And then 4, what are you going to say?
Now you can prove congruency between the two triangles, side
And
angle
how you
side.
how you going to letter them? You got to letter them correctly. That because the next quiz I'm going to do, you're going to have to write the direction of the sides correctly, and the way you point to the triangles are going to have to be congruent.
And the first triangle will be EDH, and the second triangle will be GHD.
It's congruent to triangle GHD. And that's because of,
Side angle side.
okay, side angle side. And then 5, what are you going to say?
You're done.
No, then you have to say therefore,
Oh, therefore,
angle GBH is congruent to angle EHD, because why?
parts of congruent triangles.
Okay, and the book says just write CP, corresponding parts of congruent triangles. But what I'm telling you is this, that you have got to get the lines written exactly right on the next quiz. You got to get the points on the triangle to correspond. And you got to do the proof in this manner. Given, statement, given. All right? And if it don't correspond, then it's going to be wrong. Because it's important that's a way we do it. So 40. So this thing is a rhombus. And so they want you to prove this. That angle BCA is congruent to angle EAC. So it's BCA is this angle is congruent to DAC, this angle. Okay. And then this is, no, it doesn't say it's a rhombus. It just says that this thing is ABC, BC, because if it stated it was rhombus, you could do alternate interior angles of two parallel lines cut by a transverse. So this is given. So BC and AD for this one and this one, and AD. So how are we going to go about doing this?
What about line AC and
Okay.
line CA? And you got
But,
side,
but
side,
why
side.
are you doing that? What is the ultimate thing you're going to try and show?
Angle BCA, BCA. Yeah,
Can you say,
I want to prove that these two triangles ABC and ADC are congruent.
Okay. And then you'll be corresponding parts.
Right.
Okay. I just want to know where you're going. 3. So in order to do that, you're saying what?
Line AC is congruent to line CA, reflexive. Yeah, do you need to put the E in the middle?
No.
yeah, that's what I'm
No.
saying. Does the E doesn't matter?
No. You just, the line would be just the endpoints.
Okay.
Then you would say what?
So, example, I'm just gonna ask this question. What if, like, you have this on the exam and you say, like, AE is equal to CE? Does that count wrong?
Well, it'd have to be, you'd have to give a reason for it.
I'll say, given?
It's not given. In this problem, it wouldn't be given. But I don't, if you're saying, you could say it if there would be a way in which you could say that it's true, or if it were given to you as true. But here it's not given to you as true, and there's no way to make a statement that it's true. So what's the next thing we're going to state?
Triangle ABC is congruent to triangle CDA.
Okay, triangle. And what's the reason for that?
Side, side, side.
Okay. And then you'd say what?
Angle BCA is congruent to angle BCCP.
And what you should say is therefore,
Oh, therefore, yes, yes, yes.
angle BCA congruent to and its corresponding points. Okay. See, this section 33 through 43 said proof. So that's why I wanted to be really precise. It's proof, and you have to go.
Is that CDA or CDA? So supposed to be CDA, right?
Yeah, it's C, oh, this is D.
Yeah, that's what I'm saying. See,
Okay,
on the phone,
sorry.
it's supposed to be CDA.
Okay, thanks.
Oh, can you glance it?
So 42.
Okay, I'll do it.
It says the triangle ABC. I gotta draw this thing out. Okay. The thing we're trying to prove. It's a triangle ADB. Congruent to and then
Professor, why isn't there isn't any line notation above AD and CD?
it's just saying they're equal. It's just the lengths are equal, not if they were talking congruent, then
Okay,
there would be a line above them.
okay.
I got it. BD. Is and altitude. And that's a given. Okay. And then proving that ADB and CDB are congruent.
Professor, question. Line BD, does that stipulate that that's a right angle at the base of it?
Well, what's the definition of an altitude?
I'm asking.
That's what we have to do. An altitude is a line that is perpendicular to the base.
So,
So,
Which is
yeah.
90 degrees each.
Yeah. So, because BD is designated as an altitude, then line BD is perpendicular to AC by definition. And it follows then that
So you can say
BD and AC are perpendicular. And that's the definition of altitude. Altitude is a line that's perpendicular from the base to the vertex. So it has, the base is AC.
what do you call that? If you say
Professor, what's that symbol after number 3?
Oh, it follows that. I don't, that's, I don't have to put that in there. And sometimes that's just what I was used to doing. Rather than saying therefore is always on a conclusion, and intermediate conclusion is usually it follows that something is true. They don't use it in the book. So then what can we say about, can we say anything about the angles?
Yeah, angle ADB and angle CDB are 90-degree angles.
Yeah.
Angle
So,
what we could do is this, is equal to angle CDB equals 90 degrees. And that's definition of perpendicular.
There's your proof.
okay, so, right?
Now, you're going to have to do something with this right here, because you don't have congruence. You're going to have to say AD is congruent to CD.
ED,
AD is congruent to CD.
Okay.
And it's a definition of equality. Of equal lines. Now, if congruent sides are equal lengths, equal length line is congruent. So now you've got AD and CD, you got these two congruent. You got this a 90-degree angle. Those two are 90 degrees. So now what do you got?
so we're just going to just,
I guess you'd have to say line DB is equal to line BD. So you can
Okay.
get side angle
So
side.
this is, so you can say 6
And that's reflexive.
BD is congruent to BD reflexive.
Professor, you don't have to turn the letters around and make it
Yeah.
line DB.
No, what is going to be the triangle?
A, D, B, C, yep, you're right. C, D, G.
Okay.
so is BD supposed to be?
Now what you use?
I just supposed to tell me on us. Okay.
Therefore,
What? You're going to say the two triangles are congruent?
triangle ADB is congruent to triangle CDB.
What's going to be the reason?
SAS.
Side angle side. Well, that means that angle has to be between two sides.
You want to prove you have to prove the angles as well. No, we proved the angles in number 4.
Yeah, but is that angle between the two sides?
A, D, B.
Oh, we can call it 90 degrees then. Or perpendicular.
Oh,
So it isn't
no,
a side
no,
angle
no.
side.
We've proven the lines AD and DC are equal.
No, we haven't.
Sure we have, right
How?
there. Line AD is congruent to line CD. Number 5.
Okay. All right, I got the wrong one marked. So we've
Trying to throw me
proved.
curveballs.
I was trying to.
Still hockey season. I won't talk baseball for at least another month.
I was thinking it said AB equals BC. You could do it that way too. And you could use theorem 4.2, and that's two legs of one right
I have a
triangle.
question about number 6. Why you put BD is congruent to BD instead of flipping it?
Because the way the triangle, see the triangles,
The way you name the
Yeah.
triangle.
Yeah.
see you're going from here, from A to D to C on this triangle, and its corresponding vertices are C, D, and B. Therefore, DB and DB are congruent. If the triangles went the other way around, then you'd have to do it. I just want to show you something that, because my thinking was wrong. I was thinking that we had shown that these two were congruent, which we had not shown those two congruent. And that we hadn't shown these two congruent. But then you could still say the triangles are congruent. If you had this one and this one congruent, this congruent to itself, and you had two right triangles, then if you look back on page 197,
So then you use the theorem, A squared plus B squared equals C squared, showing the two hypotheses.
you could do that. But the only thing is you could use, on page 197, there's a theorem there that says you have two legs of one, I guess there's two legs. No. Okay. You could.
Theorem 4.2.
Mhm. All right. Anyway,
I have a question.
okay.
So since AB is congruent to CD, so why didn't we say it? Okay, we did. Never mind. No, we didn't. Since we have these two right here,
We don't have them. That was an error on my part.
so this is not equal to this.
No.
AB is not equal
But
to
once they're
CD.
congruent, then those two sides are congruent. But I had mistakenly, in my head, thought that we were saying AB and CD were congruent. That was my mistake. We had shown that AD and CD were equal, and therefore they're congruent. That was my mistake.
No, it's just a different approach. We can definitely prove that. We have two legs.
Mm-hmm. You have a right triangle and you could do that.
So it's just a different approach.
Mm-hmm.
So, will I be correct if I say that? Or will I be wrong?
You have to rewrite that proof, Toby. A lot of stuff you leave out. You leave out the right angle stuff. You leave out the perpendicular stuff. You have to prove the theorem 4.2. You got two legs of a right triangle. AD, DB will prove AB. You know, A squared plus B squared equals C squared. You can prove it that way too.
Oh, okay, let's see. Okay.
Okay.
Yeah.
44 says the rules for a sailboat race stipulate that the triangular sail labeled in the following figure must be the same size and shape on each boat. List 3 measurements the judge can take on each sail, so she can verify the sails are the same without taking them down and measuring them. Which triangle congruence properties apply? So you got your sailboat. So what would you do?
You'd have to measure the mast and the boom. Because then you have the sun, you know, the height of the mast, you know it's a right angle, and the boom. And then you have side, angle side, and you wouldn't have to take the sail down.
There'd be a way of doing it that you wouldn't have to climb up the mast. I mean, first of all, you'd want to get the sail taut, right? Because if they let it loose so that it bagged, you couldn't show it. They would have to pull it. Those things are ringed together right here. So you'd have to pull this end down just so that it was good and taut. Then what could you do? What could you measure? On every sailboat to make sure that it was the same. Don't climb the mast. So what would you measure? That every sailboat would have to be the same. You're showing congruence of triangles on every sailboat. So what would you do? You pull the end of that mast down tight, right?
Mm-hmm.
And then you do what? You'd measure that length, that angle, and that angle. And you'd have side, angle, side. But you could not let that mast not be tight. You'd have that end of that thing would have to be pulled down tight, because if you let it sag, one sail could be bigger than the other. And that'd be all you'd have to measure.
We know that initial angle is a right angle.
No, you don't know that. It don't even have to be right angle. Normally what those things are, those sailboats are, it'll flex up and down, because that's a hinged point. That's just a round ring that goes in there like that. And then you pull that end of that. I think what it is, there's a ring around the vertical mast, and then that goes this way, and then there's a ring around that other thing. So you pull it, swing that around, and then pull that
Like a
bar up and
hinge.
down. But that's why you'd have to pull the end of that down so that sail was taut down. Because if you didn't, then what you could do is you could leave more billow in one and less billow in the other, and you'd have two different size sails. So you pulled it down, then you measured those two angles. And then every one of those, if you did the same thing on every boat, then that would be, you'd have congruent triangles.
So that's it?
What?
That's it?
Well, you're running the race, so what you have to do is you have to verify that everybody's got equal size sail. Because if you could trap more air, if you could have more bellow in your
So,
sail than somebody else, you could have trap more air and you could go faster.
so how do we explain this now? Like, you know,
Well, you'd measure this angle right here, and you'd measure this angle after you pulled this thing taut. And then you'd measure the length of this. I'm not sure what they call it. Do they call that a yard arm?
Which,
This thing that goes out?
I think that's called the boom. I could be wrong.
Okay. If it's the boom, then you measure the boom, you measure the angle the boom has with the mast, and then you measure the end of the angle that the boom has with the end of the sail. But everything would have to be tight. Because I think there's a way that they can pull this, they can pull this down tight too, or let it loose. And I think there's a ring goes around that boom that lets it go up and down. I'm no sailor, but I just. Okay, then 46 is saying young trees are staked to prevent toppling during strong winds while the root system is developing. A tree stake kit comes with equal length ropes that are attached to the tree at the same height as shown in the following figure. If the ends of the ropes are anchored in opposite directions and at equal distance from the base of the tree, explain why the tree will stay perpendicular to the ground. So, you got your tree. Then you got, how could you guarantee that tree would be perpendicular? It says those two ropes are the same length. How would you guarantee that tree is growing perpendicular to the ground?
Well, you're gonna check it from what I say the line. AB is straight and AC is
Okay, if you want, I can let it. So I can go A, B, C, and go D.
so
Now it's given that AC is congruent to. This has got to be D to CD. Now, to guarantee that that's perpendicular, what has got to be true? The lengths of those ropes, AD and CD, are the same. So they're congruent. What else has to be in order for perpendicularness to occur? What, right? Raylan, say it louder. What?
Sorry, it's that is it stated that AB is congruent to DC?
No, it's just saying, how do you know it's perpendicular?
So that's flat level.
Okay, you have to assume that the ground is level.
Yeah, that's
yeah,
what
that's what I would say.
Or you can even verify that the ground is level if you do what?
If you say AC is congruent to
If you
CD,
tie this thing off right up here so that they're both tied off, same amount of rope around the tree, same height, then what would, so that this one is congruent to itself. Now what has to occur for that to be perpendicular? You know,
BD
irrespective of whether the
BD,
ground's
right?
level or not, what has got to be true?
BD will be equal to BD.
What?
BD will be equal to congruent to BD. To be perpendicular.
You'd have to make sure that this length and this length are congruent, same, right?
Well,
Then
they
your
told
ground,
us
then
that.
your
That's
ground
what-
would be level.
They told us that, Professor. They said it's going to be equally apart in opposite directions.
If the ends of the ropes are anchored in opposite directions and the equal distance from the base of the tree.
So we know AB is equal to CB.
But you'd have to guarantee that they're equal. Otherwise, you can't guarantee they're perpendicular. Because if he was on a side hill and he anchored one, you couldn't verify that it's perpendicular.
Would we need the angle at all? We have three sides. We have two triangles with three sides congruent.
But you couldn't have that third side. If this were a hill and you were going over like this, then this would swing down, and that distance would be different than this distance.
Okay.
I mean, that's what it is you got a rope and you're just out there doing it. In order to verify that you're perpendicular, you're going to have to make sure that these distances here are equal, because you know this distance is equal, and you tie it off at the same height. It's the only way that you could do it without having a level. I mean, it's just like, how do you know that you've got it perpendicular? Just by using the rope.
So can you say you measure line AC? See, it's equal to 180?
And so you could verify that it is perpendicular. If these two equaled each other, this one equaled that one, were congruent, and these was congruent, then this would have to be two 90-degree angles. And that's what you were arguing. Because then the ground would have to be level to do it.
Is this question similar to the one?
This is just a logical problem, is all it is. You know, if you're on any kind of ground that was slanting, it couldn't occur unless you went crosswise to the.
Is this problem similar to the one above?
I don't know what you're saying, Toby.
Is this problem similar to 45? Because it looks the same to me.
Yeah, it might be. I guess I'd have to read it closer. You know, if you were in practicalness, if you were tying a tree off, and if you had those sides equal length apart, you know, theoretically, what could happen if you were on a slanted hill and you tied that thing off? It'd be perpendicular to the slant of the hill, right?
Right.
Saying you'd have to verify, like Raylan was saying, you'd have to assume that the ground was level. But you could, if you tied it off on a hillside and it did that, it would just be perpendicular to the land as it lay.
Right. The hill, not gravity itself.
Yeah. So it doesn't assure much more than you are perpendicular to whatever the land is.
So how do we answer this? Just those two lines? Just, yeah. 80 and C?
Yeah, because, well, this is what it's saying is that, you know, if you were on a side hill and you tied the tree off so that this side and this side are equal. So if this side is equal, this length of rope was equal, and you made it the same distance up the tree, you'd just be perpendicular to the side hill.
you gotta make sure AC is
You'd have to make sure that this is level. All you've assured yourself is that you are perpendicular to whatever the ground is.
So Professor, we're gonna have the quiz on Wednesday on Unit 4-2, starting from what problem? Where did we finish up with the last quiz?
I think we stopped at number 20.
We did,
We stopped at 20 before the quiz.
Yes.
what?
We stopped at 20.
Yeah, it stopped at 20.